Greetings. Today we're going to be discussing linear equations and their graphs. Linear equations in two variables is one of the most used concepts of mathematics in different areas of knowledge. From psychology to economy, nursing to engineer, linear equations in two variables establish a relationship between two events called variable x and variable y. And through the graph of these relationships, assumptions and interpretations can be made to determine the behavior of those variables. We're going to be discussing different concepts of linear equations so that we can understand the different exercises and the material that we're going to be discussing. One of these concepts, and one of the most important ones, is slope. The slope is a number that measures the inclination of a line given the change in y and the change in x. The letter m is usually reserved for the slope in equations. Y-intercept is also a concept in linear equations, and this is where the line passes the x-axis, the y-axis. Parallel lines are two lines that when are in the same plane, they never intercept. A good point to notice is that slopes of parallel lines are the same. And perpendicular lines are lines that intercept forming a 90-degree angle. The slopes of the parallel lines are the same, but the slopes of the perpendicular line are opposite and reciprocal. As shown in this image, the tracks of a train form parallel lines, and an intersection of two streets form perpendicular lines. We will also be discussing what's a coordinate, and a coordinate is a point on the Cartesian plane. The structure of a coordinate is x and y. When we talk about contain, it means that it's part of or that it's actually on a line. And the Cartesian plane, we'll also call it the coordinate plane, it's formed by two infinite lines that intersect at the point called the origin, which is 0, 0, 0 for x and 0 for y. And it's the place where two variables or variables in two dimensions are plotted. Now there are different ways of writing an equation. The standard form, as shown in that image, is ax plus by equals c, where a, b, and c are whole numbers and x and y are variables. Point slope form, shown as y minus y1 equals m times x minus x1, where x1 and y1 corresponds to the values of a coordinate or a point that is contained in the line, and the m that is reserved for the slope. X and y are also variables. Slope-intercept form, one of the most important forms because in pre-calculus we change the y to an f of x and use it as a function, is the y equals mx plus b, where m is the slope and b is the y-intercept. X and y are the variables. So how do we calculate a slope using a formula? Well, first we need to know the formula. The formula is m equals y2 minus y1 divided by x2 minus x1, where x1, x2, y1, and y2 are corresponding to the x and y's of two contained coordinates. Slope determines the direction of a line as shown in the animation above. An example of how the slope is calculated using the previous formula is shown in the next video. So let's say we're given 2 points, points 2, 3, and we'll call that point A, and point B, which is -1, 4. Now remember, the slope has a formula, and it's separated by the letter m. So let's say that m equals, this will be the slope formula, y2 minus y1, all of that divided by x2 minus x1. And as you can see, we have x1 here and x2 on the other point. And we have y1 here and y2 on the other point. So now it's an exercise of substitution. We substitute the 4 corresponding to y2, as you can see right here, subtracted by y1, which is 3, divided by -1, which is x2, minus x1, which is 2. Solve the numerator and the denominator. 4 minus 3 equals 1, -1 and -2 equals -3, and we rewrite that fraction as -1/3. That's the slope of those 2 points. Now we can also calculate the slope using a graph. First, we identify 2 points in a line on the coordinate plane, count the spaces needed to move upwards and or downwards between the points, and then count the spaces needed to move forward or left between those 2 points. The upward and downward movement corresponds to the change on y. The forward and backwards movement correspond to the change in x. As you can see here, we have this point right here and another point right here that are contained in the line. If I want to move from this point to this point, I have to go up 1, 2, 3, 4, 5, 6 times. That's the rise, the upward movement. And as you can see right here, the slope says that is rise over run, up and down, or divided by left or right. And as you can see, rise, which was 6, is in the numerator. Then I count how many movements I have to make to the right to reach the same level of the other point. So I move 1, 2, 3. So as you can see, that run was 3. Therefore, the denominator is 3. Divide 6 by 3, which is 2. And the slope of that line, that red line, it's 2. Now finding the equation of a line. The equation of a line can be found when we are given certain information. For example, we need the slope and the y-intercept. We could also have 2 points contained in the line, a contained point and the slope of a line, or the graph of a line. As shown in this video, we can calculate the equation by given 2 points. In this other video, I show you how to graph a line using Desmos. You open Desmos, and as you can see, on the bottom, we have 3 different blocks. The first block corresponds to the variables, second block corresponds to the numbers and the operations, and the third block corresponds to function, movement from left to right, or erasing something in the equation. We also have the Cartesian plane right here, and we have the sets of functions that we're going to be working if we work on trigonometry or whatsoever. For this purpose of this video, we do not need that button of functions. Now in this space right here, we write our function or our equation without the variable y. So in this case, if I want to graph y equals 2x minus 3, I just graph, or I write 2x minus 3. As you can see, I can change the dimension of the graph. I can zoom in or out horizontally and vertically. This way, we can look into more details in the graph. Like for example, let's say I want to find or look where the y-intercept is actually at. So I move closer to where I think that point is at, and as you can see, -3, which corresponds to the -3 in the formula, it's the y-intercept. I can graph different functions. Like for example, let's say I want to graph another equation, and I want to graph 1 divided by 2. I just simply type 1 divided by 2, and automatically I will have right here a fraction. I move to the right and write the x. And let's say I want to subtract 3. As you can see, the blue graph now appears corresponding to the color that I'm given to each equation. And I can graph multiple equations on this Desmos. Now, let's take a practice. Click here or click on the link below to take a quiz corresponding to what I'm giving. Thank you.